All right, folks, it's 11 a.m., so let's get started. Thanks a lot for joining and making the time, and welcome. If you can hear me, please send me a note so I know that the audio is working. All right, I got a couple of, I got a couple of notes, so it looks like we're good to go. All right, so this is going to be an email forensics workshop. So I'll start out by doing a little bit of an introduction and the agenda. So let me share my screen with you here, and we can walk through it. So let's do this. All right, so you should see a presentation here. This is not going to be an entire PowerPoint presentation, but I have a couple of slides that I'll show you as needed. But to introduce myself, my name is Arman Gangur. Some of you may already know me. I'm the CEO at Metaspike, where we develop digital forensics tools. We are focused on email forensics and cloud forensics. So as part of that, I do quite a bit of email work, both with servers, APIs, logs, as well as examination of individual emails and email systems for business email compromise, fraud, and that type of work. So I look at emails quite a bit. And in this presentation, my goal is to talk about a few things. Email forensics is a pretty broad topic. There is the matter of server-based forensics, where you investigate email systems and logs and audit logs and that type of scenario where you can conduct an all-out investigation on multiple mailboxes. And then there are cases where you investigate individual emails or server metadata or a combination of those things. In this first webinar, my goal is to talk about email forensics generally, some general topics that you can use to investigate pretty much any email and without very sophisticated tools. And then we might have some follow-ups to this that expand on some of those, or maybe get into more server work. And perhaps in the future, we're also thinking about maybe making an email forensics challenge where we can put out some puzzles or scenarios, and everyone can join with some solutions, and we can maybe walk through them together in a workshop again. But for now, let's talk about today's topic. Today, we're going to look at the visual appearance of an email as in an email printout, and then we'll talk about email data and metadata. So in electronic email, talk a little bit about server metadata, what that is and how we can use it, and then forensic preservation challenges, and then I'll leave some time at the end for questions and answers. So let's look at a suspect message first. I'll share a different part of my screen now. So let me switch over to this screen here. So here you should be seeing my entire screen now. Let me see if I managed to do that. All right. So I'm sharing my screen where you should be seeing an email as a PDF. If you're not seeing this, please let me know so I can correct it immediately. So let's assume that we are involved in some type of investigation. It could be litigation or let's see. I saw a note that says that the screen is black. Are we supposed to be seeing something? I don't see it. So let me back up a little bit and stop the screen share and redo that. Just a second, because it should not be completely black. So let's see here. All right. So you should be seeing a PDF of an email right now. It should not be black. All right. Thank you, Craig. So I see that it's not blacked out, so we're good. Okay, so let's start with this email printout. So this happens quite a bit when a case is starting, especially in litigation. You don't get all you need at the beginning. A lot of times you get produced a printout of an email or even a screenshot or something even worse. So the first thing I'm going to look at is a PDF of an email and talk about what we can deduce from such a PDF. and then we'll go into some more detail later. This is close to the worst case scenario. We don't want to work with a PDF, but it happens a lot. Now, how could we leverage this to get what we need as in a native format email ultimately? So this is a PDF printout. So I'll walk you through what I look at here. So a lot of you might have different experience or different methodology, but this is how I go about looking at a PDF like this. So the first thing I look at is, okay, this is a PDF. It looks like an electronic PDF with text on here. So I'll zoom in here to see if this is a vector PDF or a raster PDF. And you see that it is crisp all the way through as you zoom in. So this tells me that most likely this is electronically generated, so it's straight printout rather than something that was printed on paper and then scanned back in. If I look at the properties of this, I see a few things here, but actually before the properties, I'll talk about some of the things and then we'll revisit that. So the first thing I'll look at here is the layout. What does the layout of this, let me zoom in a little bit so it's clearer. What does the layout of this tell you? I'll give you a second to think about it. You might have seen this type of print layout before, and that is a clue on itself. So where did this get printed from? If you haven't encountered this before, this is a printout that looks like it was made from Mac Mail, so Apple's desktop mail client. And I can tell that from just the general layout of it, as in, these metadata fields are laid out on the side in a certain order, and then their values are here. On the right side, we have an avatar for the user. And if the user doesn't have an associated contact picture, then you would see the first, the initials of the user's name. So that all seems consistent, at least to me, that this is from Mac Mail. It could be another email client that produces something very similar or identical, but I'm putting it in the back of my mind that there might be some Mac Mail involved in here, at least in the printing of it. And as far as Mac Mail goes, we look at a few things. For example, if the message was saved in a certain format and then manipulated after the fact, then you might see that some of these items here are misaligned, as in the first letters of these. I've seen some cases where those letters were misaligned and some were indented a little bit when they shouldn't have been. So that's a clue. It looks like this message was not altered after it was printed to PDF at least. So these are all crisp and lining up nicely. There's an avatar here. Another clue sometimes is a little paperclip symbol up here. If there's an attachment or if there is an image there that the email client treats as an attachment, there might be an attachment paperclip symbol. And if that's out of place, that could be a clue too that the message was derived from something that had an attachment. I don't see that here. So let's look at the body and talk about what this looks like. So it's a pretty simple message. I see essentially three messages here. There's one message where somebody's writing a simple message saying, any news on the new hire, Kenny? And then somebody's replying to it, apparently, and they're saying, yes, tomorrow is the date of hire for Benny, thanks, Ernie. And then in doing so, their email client is creating a code string here, so they're coding that older message, it seems. And then there's a response to that where Kenny says, great, I'm copying Alessandra as well, Kenny. So it's a three-message conversation like I showed in the presentation. So what can we see from here? Well, a few things. The message bodies here are very simple and there's not too much to deduce from there, other than maybe somebody's writing style, and that's not really my expertise and what I look at. But one thing I can tell right away is that the code string here and the code string here are different. So there might be two different email clients at play here. And let's look at that for a second. And another thing that I actually skipped over was the metadata for the PDF, because after I talked about the Mac Mail thing, I wanted to look at the PDF properties. So that's something pretty simple too, and I'm not going to get into a PDF exam here. But even if you look at this very simply, you see that this is consistent with mail, so it must have been printed from Mac Mail. There's some PDF producer metadata here that's consistent with what you would get with macOS Catalina, and it's built-in PDF conversion system. So that all makes sense so far. So let's look at these code strings. So I'll switch over again to my presentation for a second. All right, so code strings. This is something that's kind of interesting, and it is helpful in determining email clients. So each email client and different versions of it has a way of coding older messages. And just by looking at a code string, you can deduce sometimes what email client might be at play. So if you look at these examples here, for example, if you have an email message that was sent from Gmail or G Suite, you might have a code string that looks like this. Whereas if it was sent from Apple Mail on a Mac or on an iPhone, then you might see a slightly different format where it starts with on again, but it starts with April rather than the day of the week. And then after the AM, there's an additional comma. So there's a slight variation there that you can pick up. There's a comma here before the @ so it's different than what you see with Gmail. Yahoo Mail's web interface looks quite a bit different. It starts with the full day of the week, and then a date, time zone, and the sender's email after a comma. And if you had a plain text message, then when you reply to a plain text message with Outlook, you get something that looks like this, with 5 hyphens on either side, original message, and a selected subset of metadata listed here. And this is not that simple, because the same email client might also have variations of it. For example, there were some Gmail code strings a couple of years back where there was an additional comma, I believe, after the AM. So it's good to have a repository of these that you can refer to, so you can figure out potentially what email client might have been used there. And I'm thinking about making such a repository in our community, maybe a wiki type thing where people can contribute. So I'll list some of the ones that I'm familiar with, and if anybody's using some exotic email clients, then they can chime in with what code strings that current version of their email client with a specific email provider type generates, and we can have that knowledge available to everyone, or at least the examiners. So let's go back to what we were talking about on the PDF here. So switching back to the PDF, so this one here looks to me like, as in the example I showed a little bit earlier, this is consistent with what Yahoo's webmail code strings look like. So this says on Tuesday, somebody at gmail.com, Kenny, wrote, so this code string would have been generated when Ernie replied to that message. So Ernie's domain is example.com, but it looks like he might be using Yahoo webmail, which could be perhaps he's on Yahoo Business, for example, with a custom domain. So just the fact that he has his own domain doesn't necessarily mean that he cannot be using Yahoo. So that's what it looks like. So let's keep that in the back of our mind in case it comes up later as a data point. So Yahoo webmail perhaps might have been involved. And then there's the additional code string here, which looks consistent with the Gmail web interface or G Suite web interface that we've seen earlier. And that kind of makes sense because Kenny Galloway is using Gmail, so he might have been using Gmail through the web. But let's also keep that in mind, that there's a distinction between Gmail over web versus Gmail through an email client like Outlook. So I'm noting in my mind that probably he's using Gmail on the web. So let's pause here for a second and think a little bit about what we see here. Are there any problems? Do we see any red flags that we could write down without even getting into or having access to the raw original email message? Well, let's scan through, starting from the bottom of the message. So I don't see any red flags here, just a simple sentence here. Let's look at this, this code string here. So it says on Tuesday, January 7, 2020. So the first thing I would check here is, was January 7, 2020 really a Tuesday? Because that's a mistake that people make, believe it or not. They would change a date, but they don't pay attention to what day of the week that date happens to be, so they might end up with something that doesn't jive. But in this case, I checked and January 7, 2020 was in fact a Tuesday, so we're good there. This is the time of day, so I don't have a problem with that. But here I have one problem. It says January 7, 2020, 11:25 a.m. PDT. PDT stands for Pacific Daylight Time. But in January, Pacific Time would be observing daylight savings, would not be observing daylight savings. because it's in winter. So it will be Pacific Standard Time. So I would expect to see PST here, at least the way Yahoo Mail codes messages. So if this was truly January, then this should have been a PST time zone, time offset. So, excuse me. In my mind, that's a red flag right there to think about. It's not something that'll absolutely and conclusively prove that the email is fraudulent, but it doesn't make sense, the timing of it. And here's another thing this tells me. If this message was manipulated somehow, the date of it, the date must have been changed by quite a bit, because daylight time in Pacific time zone starts in March and goes all the way to November. So it's a time of a few months at least, and this is from January. So it had to be at least manipulated by a couple of months to have that type of daylight versus standard time discrepancy. All right, so let's look up here. There's this other code string here. This one still has the same day, so Tuesday, January 7, 2020. This is 11:31 a.m., so a little bit after, 6 minutes after the earlier message. AM, we don't see a time offset here. That's consistent with what Gmail does, so I don't have a problem there. And the person's email address, so that's fine. And here we don't have another code string. And looking at this, we see the sender, Kenny Galloway, KG as the avatar. We have their email address here, subject as a reply prefix. We have the date here that shows 10:32 a.m. So we were talking about 11:25, 11:31. Here we went back to 10:32. So this, it might have made more sense if this was 11:32, because you would expect that to be later than the original messages. So that's something to think about, and this might again play into our observation here with the daylight savings. Perhaps there's a daylight savings issue and that's not reflected correctly the way the email client renders this. So I chalk this up as another red flag that doesn't really make a whole lot of sense. And then we have the recipient here and a carbon copy recipient, which makes sense. He's copying somebody named Alexandra, so presumably this is their email address. So that's what we glean from the email message. So to summarize, it looks like an electronic copy printed straight from Apple Mail or something along those lines. We have a couple of red flags here with the timing of things, how the date reflected here is earlier than the earlier messages dates. And we have a time zone offset issue where this should have been a standard Pacific Standard Time offset where we see daylight time. So now let's dive into the message data and metadata. So let's talk about what we would get if we managed to get the original underlying message. So by this I mean, you know, the header of the message body, all the header fields like message ID, in reply to references, trace fields, content length if it's there, MIME boundary delimiters, DKIM signatures, and all that. So let me pull up what this message looks like and let's take a look at that. So let's assume now that we managed to get an electronic copy of this message. All right, so here's what the electronic copy of the message looks like. Well, to be clear, this is an EML file. So this is in the form that Yahoo or Gmail would have transmitted that message over the internet. So if you requested it, you would get it in MIME format according to RFC 5322. So let's assume that somebody went and preserved this message properly from the server without making any conversions and gave us the original MIME format of the message as you would get it. At this stage, you don't want to ask the message to be in PST format or MSG format or something else, because that requires a conversion. And when you're doing this type of work, conversion is bad, because every time you convert, you're moving away from the original format, and you've seen a little bit what that does. It'll throw things off and you'll be limited in what type of analysis you can do. So in this case, since we're dealing with potentially Yahoo or Gmail type email, then ideally you would want this to be in RFC 5322 or aka MIME format. So let's take a look at what we see here at the original message. So I'm going to start from the bottom up to show you what we have. So the first thing I see here in purple are some markers. So these are the MIME boundary delimiters. And we can glean some information from them, but the first thing to note is they start by being declared here as the MIME boundary. So you want this to be consistent across the message. So here is the same value here, same value here, and the same value here. And when they appear in the body of the message, they start with, they are prefixed by 2 hyphens, and the last one is also suffixed by 2 hyphens. So that's something to keep in mind to make sure they're consistent, because most email clients will do this properly, and they need to be unique values and match this. So the purpose of this is to separate the sections of a message. So here, for example, if you read what this header field says, it says content type is multi-part alternative, and it declares a boundary. So this tells me that this message has multiple sections, and the sections are alternative to each other. So it's the same content represented in different ways. So in my message, it's going to be 2 versions of the message. One is the text version, and the other one is the HTML version. And there's a certain order to this too. So these MIME parts should be ordered in increasing complexity. So the first one should be the plain text in this case. The second one should be the HTML version. And the reason for that is when the recipient, the receiving email client receives this, it renders the last MIME version that it's able to handle. So if you are dealing with an email client that's plain text only, it would start parsing the message and it would get the text version, and then it would hit the HTML version. It would know that it can't deal with that. It just show you the text version of the file. So in this case, our copy satisfies that. So we have a multi-part alternative message with a certain boundary. We have the text version first. We have the HTML version second. Makes sense. The boundaries are consistent among each other. They're suffixed and prefixed correctly, so I don't have a problem there. If you had a message here that says something like multi-part mixed, for example, then there would be typically a message with an attachment. So if I saw something like this in this message where I'm not expecting an attachment, then I would be cautious, but we don't have that problem here. So we have a message that says multi-part alternative, and it is 2 body types. So let's look at these body types. The first thing that I would look at here is to see if the alternative contents are matching each other. So we have a message here with 2 types, right? One of them is content type text plain, character set is UTF-8, and encoding is coded printable. So this is coded printable, encoded UTF-8 text and plain text. Same thing, coded printable, encoded UTF-8 text, but this text represents HTML. So how do we see the HTML of this? Well, an easy way is to actually have this rendered for you. Email clients are really good at this. They decode the coded printable encoding and render the HTML body of the message. So if I pull this up in something like Outlook, you would get to see that HTML body. If you are not too sure about whether or not Outlook is showing you the body that you intend, then you could copy this out into an HTML file and render it yourself in the web browser, for example. But you would see it with the coded printable encoding, so it could be a little bit hard to decode. So I'm going to pull this up, and I'm going to pull up the text body, and the first thing I'm going to check is, are these really the same? Because somebody could have goofed and edited one and not the other, for example, or if they edited in something that's not an actual email client. So I'll read through this. Luckily, this is not very long, so it'll be easy. So it starts with great. I'm copying Alessandro as well, Kenny, and then we have the boundary here. We'll compare that. That's exactly the same. You might have to take a little longer to do that, but I know what I'm looking at here, so it's going to be pretty quick. And then here it says, yes, let's, well, this apostrophe is encoded, so that's normal and that's fine. Let's mark, well, here's one discrepancy. So my HTML version says, let's mark tomorrow as the date of hire for Betty. My text version says, let's mark today as the date of hire for Betty. So there's a discrepancy right there. And when you look at this in just Outlook, you don't necessarily see this unless you dig in and look at the text body. So that's important to do that manually and compare, so that you could even look at this here. We can find the same string here. Let's see. So you see, yes, let's mark, here it goes tomorrow, and here it goes today. So that's another red flag, and it's a pretty clear one. So there might be some issue here with at least that word. Somebody might have changed that probably from today to tomorrow, based on how the message is looking. Let's talk a little bit more about these MIME boundary delimiters. So we looked at the different MIME parts of the message, and I'm not going to go through the rest of the text because I know there's no difference there. So the rest matches, but that was a discrepancy there. What else could we glean from the MIME boundary delimiters? Well, a couple of other things. One of them is, let's go back to the presentation here. One of them is you might be able to glean what type of email client you're dealing with, because email clients also have their own flavor of MIME boundary delimiters. And here's something to keep in mind. The delimiters you'll see in this current message that we're looking at now will have been created by the last email client that composed this message. So the messages that were earlier, that were coded in there, like the responses or the very original message, their MIME boundary delimiters are not going to be in here, because they got stripped out and got replaced by new MIME boundary delimiters by the last email client. So by looking at this, it looks to me like we're looking at a Gmail API webmail type boundary delimiter. So the last email client that created this last message that we're looking at might have been Gmail on the web. And this is something that we had already seen before when we looked at the code string that was also consistent with what Gmail webmail code strings look like. So again, putting this in the back of my mind, so we're looking good there with that assumption. So let's go back to our original message here and look at our delimiters again. So again, we looked at this and we noticed that this is a Gmail style MIME boundary delimiter, and something that became clear to me recently, thanks to one of my colleagues, Stig from Norway, is that these actually contain some hidden dates. So you could parse these and derive some dates from them. This part actually that comes all the way up to, not including the last 2 bytes, is a date. So I can roll this all up into our Gmail MIME boundary decoder. You can get this from our website and decode this, and you find the date. So this is the date when the MIME boundary was created. And the reason that there's a date here is this, not exactly the reason, but one of the reasons. The email client has an incentive to make those MIME boundaries unique. So they need to be unique enough that they're not going to conflict with other pieces of text in the message body. And in making it unique, usually email clients utilize some information from the system, such as process IDs, sequence numbers, or sometimes timestamps, which could make for pretty unique things, especially if you include high precision timestamps. So you don't want to take the timestamp up to the minute, because somebody could create multiple messages within the same minute. So you want to go a little bit more precise than that and maybe get to seconds or milliseconds or even microseconds. So in this case, if you decode this, you see that we have pretty good precision here. After the point, we have up to 6 digits, so microsecond precision for these Gmail boundary timestamps. And we decoded this, and let's see what this looks like. So we found June 23rd, 2020 at 6:32 p.m. in UTC, essentially. Let's see if this jives with our apparent date of the message. Well, our message was supposedly sent January 7, 2020, another Tuesday at 10:32. So this is definitely a big red flag because of a couple of reasons. Number one, the minutes of this are matching exactly. So it looks to me like somebody might have easily, not only the minutes, but even the hour matches exactly if you convert this to GMT. So this is an easy way for somebody to just go in there if they wanted to shift the dates and not touch anything else and only edit the day and the month and leave everything else exactly as it is, like the hour and the minutes and the seconds, to get a quick date shift. So I'm paying attention to how these seconds and the minutes are lining up, and they're not matching the boundary delimiter. So that's a huge problem. But let's keep going, because it's not really enough by itself to make a determination yet. Another thing we can look at within this HTML body is also some signs that confirm our findings about the email client that was used. So here there's some CSS classes in the rendering of the message body that talk about Gmail. So you could observe this from other legitimate messages to confirm that this is how Gmail composes messages. So that could be another clue. So let's move on to the next things. But let's see here. I have a few questions here, so I'd like to pause for a bit before I go too far down and answer these, because I don't want it to get too late, and there's quite a few participants here, so let's take a quick break. So let's see. Well, one of the questions I had was, when we seek native or near native forms to do forensic analysis of emails, what forms we preferably supplied if you're unable to secure access to the storage medium or a PST, EML, MSG, something else? Well, I talked briefly about this. So the general idea here is to get as close to the original as possible. So if you're dealing with internet email, and that is if you're accessing the email as a client, then the best case scenario is usually the format in which those email servers transmit the messages over the internet. So in this case, for Gmail and G Suite and Yahoo, AOL, Hotmail, all these email providers, and even for Exchange, if you're connecting as a client, the best case would be EML, so RFC 5322. If, on the other hand, you're dealing with local email, that could be email that's on a workstation, like a PST or an OST file or an MSG file, then that's how it's saved and maintained during the regular course of business. So that's what you want without any conversion. If you have in front of you an Exchange server and it has an Exchange database, then best case scenario, you get access to the whole Exchange database to do what you want. You could do all types of analysis there. Or alternatively, not as good, but you might be able to export PSTs directly from the Exchange database per custodian and work with that. So it depends on the format, but ideally, for most cases where you're connecting as a client, you want EMLs. Let's see. Well, here is another question that asks me if there are any tools out there at the moment that could automatically compare, detect, and flag these discrepancies, potential tampering with visible content. The answer is not that I know of to the level that I would like, but that will be soon. So stay tuned, and I'll keep you posted there. So I'll close with the questions here. There are a couple of other things here, but they seem more like a conversation than an actual question. So I'll look at those a little later. I don't want to take too much time here, so I'll keep going, and then I'll go back to the questions in a little bit. All right, so let's get back to where we were in the message. So we handled the message body and the content type and the boundary flag. So let's look at these metadata fields that you see on the face of the message. So we have a CC field that has only the participant's email address, which could be, I don't have a problem with that. We have a to field that has the person's name and email address. We have the subject that has a reply suffix, prefix. We have a message ID. Well, there are a couple of things to look at here. Number one, something that you can use a message ID in your investigation is that these message IDs are designed to be unique. So if you're dealing with a large collection of messages, for example, somebody's mailbox or a document production, and if you're investigating a specific message that you think might be fraudulent, then a quick check is to scan the whole universe for this message ID to see if any other copies of it turn up. Because if they do, then that's a pretty good indicator that this message might have been derived from another message, because like I said, these message IDs are supposed to be unique, and this happened in some cases before. So that's a low-hanging fruit, and it's a pretty conclusive data point and good to have. In this case, we see a message ID that has some characters here, and it ends with mail.gmail.com. So I was expecting this because we had a message that was sent from a Gmail address, and this is created by Gmail, this unique message ID. One thing to pay attention to here is the domain here. So it is mail.gmail.com domain, and the message ID is consistent with a message that was created on Gmail over the web, like Gmail's webmail, or Gmail API, so something like the Gmail app on Android or something on those lines, but not IMAP. If this had been an IMAP message ID, so something you would get if you have connected Outlook to Gmail and created a message there, then you would have a message ID that goes gmail.com without the mail. So again, another data point that kind of confirms what we were thinking, that this message was likely created from Gmail webmail. So makes sense there. Here's the date. The date has a time zone. So we have the 11/30/20 date. It is in -07 time zone. So if we take into consideration what that PDF looked like earlier, you remember that the printout of this was showing PDT. PDT is -7, so Pacific Daylight Time. So if I had seen this time zone by itself, -7 by itself doesn't really mean too much, because you don't know if that's a time zone in daylight savings or if it's a time zone that happens to be in -7 during winter. But looking at the message body here, we're seeing that this is most likely Pacific Daylight Time. So again, we have the same concern that January is not a good time for daylight time in Pacific time. So same red flag, again, reiterated. We have the person's name, we don't have a problem. In reply to is one of the fields, one of the header fields that it references a prior message that this message is in response to. So it's kind of a threading mechanism, or a way to keep track for email clients which messages go together, or which messages in response to what message. So in this case, we were thinking that although Ernie was using example.com, based on his code string here, he might be using Yahoo webmail. And this kind of confirms that, because the in reply to, which is pointing at the last message that has been replied to, has a Yahoo, mail.yahoo.com message ID. So most likely this is Ernie's message, and it's showing a Yahoo message ID. So it was probably from Yahoo. Here is another hidden timestamp here. This is an epoch timestamp, and you can convert this online using any tool. I have created something really quick last night to do this here. So put this in and you get a pretty high precision timestamp potential. In this case, we have up to millisecond precision. Again, the reason for this high precision in these timestamps is to reinforce uniqueness. Sometimes you could go up to microsecond precision. Here we don't have microseconds, but milliseconds. And again, this jives with what we were seeing in the Gmail boundary delimiters. We're seeing June 23rd, 2020, 6:31:05, and some milliseconds as a hidden timestamp. So this should match the timing of this message, this 11:31 a.m. message from Ernie, and the minutes match, and the hour matches when you time shift for Pacific Daylight Time. But the date doesn't match. We have June 23rd here, we have January 7th here. So another red flag based on the hidden epoch time and the message here. Same thing here, this references field again references any other messages that are involved in the conversation. So we have the same hidden timestamp here from the exact same message. So they're good. And we have the same message ID. We have a Gmail message ID here. All right, so let's move on here. MIME version 1.0. So we don't have a problem with this standard header field for MIME at the moment. We have a received by header. We have an IP address here, SMTP ID. We have a date here that reflects the date which we believe to be incorrect, but we'll ignore that for now. So that's the date that this header field reflects. And then the next thing is something that reads X Google DKIM Signature, and right after that there's another one that says DKIM Signature, and they look very similar. So here, let's have a very quick break and talk about DKIM signatures, or DKIM in general. So let me share with you the presentation again. All right, so DKIM is a mechanism for an entity, a transmitting entity, to claim responsibility for a message. So what happens is, let's say that Gmail or Yahoo is processing and transmitting a message, and they take the message, they hash the body of the message, and they take a subset of the metadata fields or the header fields from the message. They join that all together and digitally sign it with their private key. So if it's Google, for example, then Google is using their own private key and sign that message. And then they publish the public key that's associated with that private key as a DNS record. So the recipient fetches that public key and they attempt to verify the signature. If the signature verifies, then that's pretty strong evidence that the message hasn't changed, at least since Google signed that message, because the perpetrator would not have been able to access Google's private key, so chances are they're not going to be able to forge that signature. So finding a valid signature there is pretty important. So this is very powerful because essentially DKIM is giving us the message body as a whole, the hashing, the pretty powerful hash, and a subset of the metadata fields and their integrity. So let's take a look here to see what this means for us. So let's go through what this DKIM signature looks like first. So it starts with a tag that says v = 1. So this is the version of DKIM, so it's going to be 1 for now, as per the specification. The A tag tells you what algorithm was used. So in this case, it's the RSA SHA-256 algorithm that was used to create the hash of the message body. The C tag talks about canonicalization. So this is how the message body and header fields were processed before they were hashed. Relaxed means that there's some tolerance there for changes. For example, some line breaks were removed from the end of the message. So this is to build some tolerance for transmission introduced changes to the message body. So in this case, it's not strict canonicalization, but it's relaxed for both the header and the body of the message. This is important to have listed here because when we calculate our own hashes and verify, we need to follow the same prescription here to get to the same result. The D part is arguably the most important part. This is the entity that's actually claiming responsibility for the message. In this case, it's a domain called 1e100.net. And the S is a selector. So this is the selector that you would use to retrieve the public key from DNS records. So why is the domain part important? Well, here's why it's important. If you have a DKIM signature here, but instead of saying, for example, gmail.com, it said something like bluewaterproperties.com or some other domain that's unrelated to the conversation at hand, then that DKIM signature is not good because somebody that owns that domain could have created their own DKIM signature and published their own public key there after they forged the message. And you might verify the DKIM signature and you find that it verifies, but that doesn't mean anything because there's no authority behind it. So for the DKIM signature to be meaningful, it has to have been created by a reliable entity that's involved in the transmission of the message. So in this case, Gmail makes sense. Well, you might ask what this 1e100.net domain is. That's a Google-owned domain. 1e100 is the scientific notation for Google, and Google uses that domain for their internal use. It's not a client-facing domain, but if you read up on it and research it, you'll find that Google has some documentation on it. So it's one of Google's domains, so we don't have a problem with that. But I guess the bottom line here is before you roll up your sleeves and even get into calculating DKIM signatures, you want to look at that domain to see if the domain even makes sense. If the domain is not legit, then the DKIM signature is not useful to us. The second thing is, so after the domain and the selector, we have the H tag. So this lists the header fields that were utilized in the calculation of the signature. So in this case, the fields were selected in this order and they were concatenated. If any of these listed fields is not in the message, then it's just listed as a blank. Yeah, so, and if they're listed multiple times and if they don't appear multiple times, then the subsequent appearances will also be blank. That's something to keep in mind. The BH is the hash of the body. You see that these two DKIM signatures have the same body hash here. So likely they were calculated at the same point in time or at the same stage in the email's transmission, let's say. But the signatures themselves are different. And that makes sense because number one, these signatures were created by different domains. So different private keys. This is gmail.com, this is 1E100. And also the selection of header fields are different. This has a different set of header fields. This is a different set of header fields. So one thing I recommend everyone, if you haven't done it and if you're interested in using DKIM, is that you at least do one DKIM verification end-to-end manually to get yourself familiar with how it works and what it gives you precisely, because that'll be very helpful in thinking what it means, what you can use it for and what you can't use it for. We have a blog post that kind of walks you through it line by line, so you could follow that along in an example and get it verified. And then once you've accomplished that, then you can use some freely available tools to calculate DKIM signatures and make things faster. So going back to here. So I wanted to show you something really quickly about what this public key looks like and why that part is important. For example, let's say that we wanted to verify this DKIM signature. I'm not going to do that as a whole right now because that'll be a whole different presentation. But let's try to get this public key. So we could go to, for example, something like MX Toolbox. They have a nice super tool here that allows you to do different kinds of lookups. So we could do a DKIM lookup and go find our domain here. Let's see here, there's my gmail.com. And then I can put my selector here, and the selector is this. And the reason for a selector is gmail.com doesn't have a single key. They have multiple keys that are set at different times, so they have different selectors based on timestamps. But when you look it up, you get a response that looks like this. So type of the key, and here's the payload, a long public key. So you use this key in your verification, as in you take the signature that they have listed here, and you verify it using that public key and the hash that you calculate, and your version of the metadata fields you get in this message, and you see if it matches. And just to reiterate, this is a very powerful data point because, like I said, the end users are not in control of this. So when I examine a message, I much prefer looking at a message from somebody's inbox than from somebody's sent items folder, because sent items folder doesn't have the DKIM signatures. You're going to have just the bare minimum of email headers there. But once the message is transmitted and goes over, then while it's being transmitted, it gets assigned these DKIM signatures. And that's very valuable to decode. Next up is the authentication results. So this is a field that an entity inserts there. In this case, it's Google's authentication results. And it's a summary of the authentication results as Google found them at the time. Now, is this valuable? Well, to an extent, it gives you a snapshot of what Google looked at and what they found at that time. But this is very easy to forge, and it doesn't have a key associated with it, so it's not something that nobody can edit. So it doesn't really give you much confidence. So just the fact that I see this here and it says DKIM pass, for example, doesn't mean anything to me, because this might have said DKIM fail, and somebody could have edited the email and made it pass, and I wouldn't know about it. That's why you have to do your own verification. But let's talk a little bit about what you see here, at least. So this says Google checked this message. It found that the DKIM passed. So at the time they looked at it, based on what this header is looking right now, DKIM passes. The entity was gmail.com. Selector was this, matching this. And the header B is the identifier for what DKIM signature they verified, the first 8 bytes of it. So in this case, they're talking about this one here. The first 8 bytes matches that. The second lineup is SPF. So SPF is the Sender Policy Framework. This is a framework that is used especially for having your email sending business handled by somebody else. And through this framework, you give them permission to send on your behalf. So if you're using, for example, some type of email marketing tool, then instead of you sending through gmail.com or Office 365, you could give that third-party entity permission to send on your behalf. So in this case, it says that SPF pass google.com domain of kcalloway@gmail.com designates this IP address as permitted sender. Now, this is all entirely expected because this is Gmail's webmail, and gmail.com is essentially designating their own IP address as a permitting sender. That makes sense. We can verify this here to see if this is still valid, just as a maybe a point in time check. Like, has this changed since then? So you could do, you can use the same tool to do a sender policy framework record lookup. And there's a redirect here, so we follow this, and it says that there are a few include blocks here. So let's start by looking at them. So here, let's see what our IP address was: 209.85, 220.41, 209.85, 128.0, and this is 17. So if you look at this entire range, this goes from 128.1 all the way to 255, 254. So that range, that IP range, covers our IP address here. Like I said, this is no surprise because it's Gmail's own, Google's own IP address permitted to be sending on behalf for Gmail, essentially. So totally expected. The next thing up here is DMARC pass. So DMARC is another framework that essentially leverages the power of DKIM and Sender Policy Framework together. And it has a feedback loop, so it allows entities to report back on what they encounter during the transmission. So in this case, it's saying that for this domain, the DMARC policy was none. So if the message was sent from gmail.com, then there's no policy to be applied to it, even if it fails DMARC. If it was sent from a subdomain, so this is the subdomain policy. So if this message had been sent from a subdomain of gmail.com, and if it failed DMARC, then Gmail instructs you to quarantine it, if you believe what this says here. We're going to verify that. And the disposition is none. So disposition is essentially what happened as part of the authentication results, and no policy was applied to it. So that makes sense because DMARC passed. It didn't fail, so no problems there. But if you wanted to verify this, we can take a look at the DMARC records for gmail.com. Let's do another super tool lookup here for DMARC. You'll see that we have the policy for the domain is none, subdomain policy is quarantine, and the receivers are, these are the email addresses that would get any reports. So in this case, the report should be sent to mailauth@google.com. So if DMARC fails or succeeds, whatever those reports or their aggregate would be sent to that email address by those transmitting entities. So like I said, in summary, authentication results, good to have. It might make sense for you to go verify those to see if they're still the same. If they have changed, then it might be an indicator that the timing might have changed since this message was sent. But by itself, I wouldn't trust this entirely because it's easy to fabricate this data point. Same thing here about Sender Policy Framework passing, same IP address, one. We have a received header here. So at this point, we're getting into the trace headers where as the email is passing through hops, servers that are processing it are adding new received headers, new trace headers, and they're piling up one on top of each other. So here we have one where one Google server is receiving it from another Google server. There are some Google related IP addresses here. But there's one thing here that's not easy to notice because this program highlighted this a little strangely, but here's another hidden date. It says 2020, 0623, 11/32/31. So this is another date, and this is the date, in my experience, based on other messages, this is the date that this message got processed through this hop. So this points to June 23rd, 2020. And most likely, when this person manipulated this message and they maybe did a find and replace, or they went through and scanned the message and changed all the human legible dates, they missed this one because it's not that easy to spot. So there's a little pointer here that this might have been the actual time this message was processed. Although at the bottom of this, there's another date, and this appears to be January, so there's a discrepancy here. Return path. Return path is essentially an email address that's also known as the envelope path, or there are a number of names for it, but this is the address that you would use through SMTP to indicate where the NDR reports, the delivery issue reports, and bounces should be sent back. And the reason for that is this: you may not want those bounce reports to be sent back to your own mailbox. Let's say again that, to give you an example, let's say that I have my own email address at metaspike.com, but I'm using an email marketing tool that sends emails on my behalf to a number of recipients. And if some of those emails bounce, I don't want all those bounce reports coming back to my own mailbox because I have no use for them. So the email marketing software sets that return path to their own, not their main email address, of course, but a programmatically generated email address for me as a recipient on their end. So reports go there, and then they assess those reports and determine, if I'm spamming people, how many of my emails bounce back, and what to do with those bounces. Perhaps remove some of those people from my email marketing list. In this case, there's no such setup. The person is sending from their own email address, and the return path is their own email address, so it would bounce back to their own email. And you might have seen this yourself. You send an email from your own mailbox to somebody, you type the email address wrong, and it bounces back. The report comes back to you. So no problem there. Another received header here, another hidden date. Let's decode this while we're here with our little date decoder here. Another Unix epoch date, again, points to June 23rd, 2020, around the same time, millisecond precision in GMT. So again, reinforcing our finding that the date on this is most likely wrong. Another received header, another date. Once again, we're seeing in both this one and this one the wrong PDT time zone here as well. So incorrect daylight savings time offset rather than PST. And finally, delivered to a French. So this is supposedly this message got delivered to this person's mailbox. Well, that makes sense because this person was one of the recipients. So this tells me that most likely the copy that I'm looking at right now might have been the copy that was received by Alessandra rather than the copy received by Ernie, because this is where allegedly it was delivered to. Okay, so let's take a quick pause here and think about what we've just looked at. So we basically found a number of conflicting data points, especially around date and also around the contents of the message. So huge red flags. And word was inconsistent between the text body and the HTML body, and there were a number of hidden timestamps in the MIME boundary delimiters, message IDs, trace fields. Sometimes you might find some in DKIM signatures too. There might be a tag that says T, and it might have an epoch timestamp. In this case, I didn't have that, but we had quite a few wrong timestamps, and that's also reinforced by the fact that we're seeing PDT time zone when we should be seeing PST in January for Pacific time. So we've seen quite a few issues on the message itself. To sum this part up, you see that the method I take is to look at the message line by line. I usually start from the bottom, and to leave no stone unturned, I scan it line by line and try to evaluate what I'm seeing in every line. In this case, you saw me skip over some things. That's because I knew what it was in the message bodies and stuff, so I didn't really analyze it in too much detail, but normally I would look at that potentially character by character. We have another hidden issue here. I don't know if any of you noticed this, some of you might have. And I'll show you this in a different way that's easier to illustrate. So let me pull this up in Ultra Edit. Let's show you one more red flag here. Okay, so if we look at this part of the message, this MIME part, this is encoded printable. And coded printable encoding has a maximum line length of 76 characters. So that means that the encoded message should not be exceeding 76 characters. And as long as a popular and reliable email client created this, they would observe that. But when you look at our message here, we have this line here that all these message parts are following. So they're all lined up, but a few of the lines are misaligned and they're sticking out. This shouldn't be. So there's a problem here. And if you look at the column number I'm at here, so I'm at column 76 here, if you see. So this, the width of this is 76 characters. And then the equal sign indicates that there's a fold there, so it got folded. So this also tells me that most likely these lines that are sticking out might have been manipulated. Well, for example, for this one, it's easy to see why that might be. If somebody changed the date, then that might automatically change the length of this line. If they didn't know to go back and readjust for proper coded printable encoding, then that's an easy giveaway. Perhaps they changed some other things here too. So we don't know exactly to what extent they manipulated this email. Well, I know, but we don't right now. But we can see some additional clues on what might have been manipulated, which is also good to know. So keep that in mind, the 76 characters and coded printable. If you see it as a block, then it's good. If you see some items sticking out, of course, you need to be using a fixed width font so that everything lines up. If you use something with variable length, then some characters might be wider than others, and you might not be able to spot that exact line. But with a fixed width font like Courier, you would see those jutting out, and that should not be. Now, let's turn our attention to something else. And I'm getting ready to wrap up here. I don't want to take too much of your time. So let's talk about a couple more things and wrap up. The next thing I want to mention very briefly is server metadata. So far we looked at metadata that's in the message, assuming that we got just the message, but nothing else. But that's not everything there is to it. There's also server metadata, and by that I mean metadata that's kept by the server, on the server about the message, and that's not included in the message itself. So for example, you could liken this to file system timestamps. You know how there would be internal file metadata that travels with the file and it stays in the file. And then there's also file system timestamps that are part of the file system on the volume that the file sits, but they're not part of the file, and they don't travel with the file necessarily unless you observe some special precautions. So server metadata is something like that, a little bit more complex because there's different aspects to it depending on the server that we're talking about. I'll give you some examples to get your gears turning. So for IMAP, for example, the most important ones that I use as far as server metadata goes are unique identifiers, IMAP flags, and the internal date attribute. So let's talk about these very briefly. The unique identifiers are integers, 32-bit values that are assigned in an ascending fashion as new messages are created in a folder. They're supposed to be unique in a folder. They might have gaps. And like I said, they're assigned in an ascending fashion. So this is pretty valuable to us for a couple of reasons. Number one, if a message is deleted, then the UID values are not compacted and they're not, that gap is not removed. So you would see a gap there for any messages that were removed. You may not know what message was removed, but you might be able to tell that something was removed from there. So that could be helpful in establishing whether or not a message was had ever arrived at a mailbox and deleted afterwards or not. If you look at the date of the message and you examine that time period in the mailbox and you don't see any gaps there, then that would be one data point favoring the fact that the message may not have arrived in that folder. So that's something good to know. The other thing is, because the UIDs are sequential, if you see a message that has a UID that's jumping around, then that could also be a problem. So let me show you some examples of that. The other thing before I do that is the internal date that's kind of important. So this is a date that's kept on the server in IMAP servers, and the date reflects the creation time of the message in the folder. So kind of like a file system creation timestamp. Normally this would track the sent and received dates of messages pretty closely, because you know the workflow message gets sent, it gets received almost instantaneously, and as it's received, a new message is created in that mail folder to hold that message, which happens pretty fast, and you get a new creation date. But that changes if somebody migrates messages after the fact, or if they move messages around, or if they take a message out, manipulate it, and put it back on the server, which is entirely possible. In those cases, you might have the internal date reflect the date that the migration or upload or manipulation took place, not the manipulation, but the sync back to the server, essentially. And I'm saying it might because it depends on how the IMAP append command was issued. If it was issued with a timestamp argument, then it reflects that timestamp. If it wasn't, then it would reflect when that append command was issued. So it's good to know. So let's take a look at what we might glean from something like this. So let me switch back to my other screen here again. Let's see. So let's take a look at what server metadata like this might look like. So I'm going to look at some logs here from an IMAP acquisition I have, just to get you kind of an overview. So we have some information here about the hashes of the messages that were downloaded, where they were saved, their flags. But here are the two things that I want to emphasize. One of them is the IMAP UIDs. And by the way, all these messages are from one folder. So I just picked up the inbox folder in this case. And you see that they're IMAP UIDs and they are in sequential order. And these are the internal dates, so dates that the server keeps about the messages. And they are sorted chronologically. So earliest date first ends with the most recent date. So a very quick check you can do here is, are there any IMAP UIDs here that are out of sequence? So if you have something like Excel here, for example, you could do something like this. Is this one larger than the other? Let's take a look. Oh, we got some. Let's mark this line. This is line 492, so I can get back here. All right, so let's look at this neighborhood here. So we have some messages here, and their dates are sequential. So we have 5.1, 5.2, 5.3. It's making sense. But if you look at the UIDs, they're not entirely sequential. They go 5, 16, 17, 18, 19, 21. But this one in the middle has a huge jump that goes all the way up almost to the end of the line here. This is at the 1500s. So that tells me to look closely at that message. So I can, in my acquisition, I know exactly what that message is, so I can pull it up and I can analyze it. But that's a clue right there that there's something odd about this message. It may not be something malicious. Maybe that message was migrated after the fact, like I said, or it was copied from another folder. But it might also be that somebody actually manipulated that message and put it back. So that's something to keep in mind. And the other important point here is that when you acquire a message for analysis like this, it's not enough to just get the message that you're analyzing, because that doesn't give you the whole picture. You want to get the entire folder at a minimum so that you can look at its neighbors and have the message analyzed in context. And I've had cases like this come up where an expert preserves just a few messages here and there, and they present them, but number one, they converted the message to another format like PST, and we can't do the DKIM verification or the content link verification anymore. And number two, they didn't get the message's neighbors, so we don't know if that message's UID was in sequence or not, and if that message might have been manipulated. So that's something to keep in mind. Let's go back to the presentation here. All right. So if we look at our message, for example, that we just looked at here, I have a printout of it from Outlook just to show you what we were looking at. This message also has a similar problem. So if you look at this message on the server, it has neighbors, and the neighbors have sequential UIDs like 74, 5, 6, 8, 9, when their dates are sequential. But this one has a UID that skips ahead. So this might also be consistent with a date manipulation or any type of content manipulation in a message that was synced back to the server. Now, server metadata is not just limited to IMAP servers, of course. There's a whole host of server metadata on an Exchange server, so many data points, in fact. And there are also server logs and audit logs, activity logs, all kinds of information. And on Gmail and G Suite, there's also audit logs. And also on both of them, there's thread IDs that help tie messages together that don't travel necessarily with the messages. There are label IDs. They may not be included in the message depending on how you preserve the message. There are internal dates, very similar to how the IMAP internal dates work. There are also history records. And this is something I want to mention again very briefly. I'm not going to get into too much detail on this because this is another relatively large topic. But let me talk to you very briefly about this just so you're aware of it. So history records are an internal part of Gmail and G Suite, and it's available in all of their plans. So even a free Gmail account has this. And the purpose of these records is to enable email clients to sync mailboxes without having to download the whole mailbox. So let's say that you wrote an email client, or you didn't necessarily write it, but let's say it's Outlook, for example, and it's talking to Gmail, and it's acquiring messages to display to the end user. The first time it connected, it grabbed all the messages that were there and preserved them or ingested them and stored them. Now the user doesn't use the software for a couple of days, and then the third day they open Outlook again and they hit sync. Now, one way to handle that would be to go back to Gmail, request all the messages again, and figure out which messages have changed and make necessary adjustments. But that's a pretty big undertaking. Number one, it's pretty resource intensive. It will take a long time and it will consume Gmail's resources quite a bit. And number two, it's just an unnecessary process. Basically, it would make the user wait quite a bit. So instead of doing that, Gmail implements this history records concept where each message that you download from Gmail API has a history ID associated with it. And then you can query that history ID to get history records beyond that point. So when Outlook does the initial sync, they get all the messages, they store the last history ID that they have, and the next time they send that history ID to Gmail and ask essentially, hey, what happened after this? And Gmail gets back to them with a list of changes to the mailbox after that point, and they list, hey, since you last asked, these labels were added, these labels were removed, these messages were added, these messages were removed. So this gives you a pretty good picture of what has changed, and you can readjust and sync just that. Now, if a lot of time passes, then those history records become out of date and you have to do a full sync. But within a few weeks or a month or something along those lines, they're stored. How does this interest us? Well, of course it interests us because history records are kind of like an audit trail, like make your own audit trail. So let's take a look at what they would look like. Let me see here, back to my screen. So let me take a look at a history record export that I just did before this to show you what this looks like. So here we have a bunch of history records. They go in order and they have messages associated with them. And I listed the metadata values for those messages. And sometimes they have associated events. So for example, these records don't have any events, but sometimes they might have events like messages added or messages removed or labels added. So you could, so for example, added label ID. Yeah, so let's look at this record, for example. Here's a history record that tells me that somebody added a label to a message, and the label that they added, so the label that they applied, is the unread label. So essentially somebody marked the message as unread, and this is the message. Right, the message is, its ID, its subject, to from CC, message ID, and the date of it. Now this history record itself doesn't have a date. So this doesn't tell us when that person marked this message as unread, but there are records before and after it that have dates because there are records that show when new messages were received, so message added records, and those records have dates associated with that message. So you can sandwich this record from both ends to determine a range when this person might have marked their message as unread. So imagine you're trying to establish if a message was read and then marked unread, or if a message was deleted or moved or anything like that, then you can use these history records and kind of use them in combination with each other and sandwich them with records that actually have dates and figure out a date range when an action might have been taken by the user. It takes a little bit of work to straighten this out and fully utilize it, but if it's something that's not otherwise available, there's no Gmail audit trail like this that you can easily access for the free Gmail accounts at least. So it's very powerful to be able to access the history records and make your own audit trail. So it's something good to keep in mind. Let's go back to the presentation here. Yes, and finally I'm wrapping up. So to summarize everything from this so far, I would say it's important, very important to preserve in the original format. Imagine if we had acquired this email in an entirely different format like MSG or PST, then a lot of those checks that we could have done would not be available to us. Sometimes in a conversion, MIME boundary delimiters are swapped out. A lot of times the message body and the formatting of it changes enough that DKIM signatures fail to verify. Another favorite data point of mine is the content length header that AOL and Yahoo uses that tells you how many bytes are in the message's payload. And if you do a conversion of the message, then the content length doesn't add up anymore. So there's a lot of investigative value in having the message in its original format. And once it's converted, a lot of times you're dead in the water, so don't do that. The second thing is to capture server metadata. So it's not enough to just get the message that you're interested in, but you should also get at least its neighbors, the folder, and any other server metadata that's available to you, any logs, so that you can look at it in context, not just the message itself, and analyze it that way. So that's it for the presentation. I'm going to turn back to the Q&A here to see if there are any other questions that I should answer real quick before we wrap up. Let's see, one of the questions is, where do you acquire Gmail server metadata as a regular Gmail user? Can you get it in Mbox with a Google takeout? Well, some of it you do, some of it you don't. So Gmail has, the Mbox exports include things like Gmail labels. It includes some information about internal dates, but it doesn't give you UIDs because UID is an IMAP thing. So if you wanted to get the UIDs, which is important for sequence analysis, then in addition to your Google takeout, you would want to do something like an IMAP acquisition of Gmail, and in that acquisition, capture those IMAP UIDs. The UIDs are available to you in the server's response, whether it be Google's IMAP server or Yahoo or whatever, but it's just a matter of capturing them. If you use a tool like Outlook, for example, you're not going to get those UIDs because Outlook is not going to make a log of them for you. So you would want to use the forensic tool. Let's see, another question. Another question is, somebody is saying, we're looking at an EML document here. Would this work in the same way? And would this information be available on MSG files? Yes, just as I was saying a little bit ago, it wouldn't work exactly in the same way, but an MSG file would have underlying mapping properties. And with a tool, you could examine those mapping properties and you would actually find other information. You might have some information that shows you who have accessed that message before, who edited it, and a bunch of other things. And you would have access to the text message body and the rich text message body and all that. But some of these investigative techniques wouldn't be available after that conversion. So if the message was originally an MSG, which is unlikely, but it could only be an original MSG if somebody had downloaded the message in their Outlook and through the regular course of business, they dragged it out to save it for archive. And then that's the only copy available to you, then that's the original copy and that's all you have. But normally in a normal business scenario, if you receive an email in Outlook and it's already sitting in your local mailbox, then you would have it in an OST or PST file. If it's on the server, then you would have it either in an Exchange database or you would retrieve it through the internet as an EML file. So MSG is kind of unlikely as a native format. Let's see. Let's see here. All right, another question I have is someone is saying, Richard is saying that they checked X originating IP from Gmail and Yahoo, and they only enter their internal server IPs, not the end user's IP. Do you know a way to get the IP of the end user's computer? Yes, that they do that on purpose as a privacy measure, because if they included all the users' IPs out in the open like that, then it would be a huge privacy issue. So they used to do that a while back, and now, I don't know about Gmail, but I believe Yahoo used to do that, but now they switched over to masking that information, and they don't give it to you. You're not going to get that original client IP from Gmail's web interface or Yahoo. You could get it in a couple of ways. Number one, if an email client was at play, if somebody was using an email client, that email client may take it upon itself to insert the user's IP in there, and you might find it there. So that's one possibility. The other possibility is if there was some type of external element in the message, like an image, for example, and if somebody requests that image through an HTTP request, then that request might have been logged, and you might get some information on who requested it and when, and you might derive some IP information from there. But just by looking at the EML from a Gmail or Yahoo webmail export, you're not going to get users originating IP. And another data point like that's harder and harder to find now is the mailer. Sometimes email clients used to have that X-mailer header field, and it would tell you what email client was used. But a lot of email clients don't use that anymore. Outlook still uses it. Apple Mail still uses it, but a lot of these webmail clients don't. So that's why it's also good to have this repository of MIME boundary delimiter formats and code string formats, so you can use those to derive what email client might have been used. All right, folks, it got a little later than I expected. It's 12:21, so this has taken a little while. I don't want to hold you up. If you have any questions that I haven't addressed, there are quite a few participants here, so I may not have been able to get to everything. Feel free to send me a message. Here's my email. You can send me a note there or find me on LinkedIn if we haven't already met. And we will have another live session of the same presentation a week from now to cover other time zones, especially Australia and thereabouts. So if you missed some of it, feel free to join that one. And I plan to have some other email forensics workshops like this to cover different aspects, maybe get into more detail in Gmail history IDs, perhaps some server log investigations or IMAP server metadata and that kind of stuff. So feel free to send me some suggestions if you're interested in this type of work and want to learn more about specific topics, or if you'd like to see some type of challenge where we put out some things and you solve the puzzles. Otherwise, thanks for joining, and keep in touch. Thank you.